I'll just record on this one. We're recording, I think. It's recording, right? Yeah, it is. Okay. This is now on the thing. I'm gonna add the other people. So they can... Okay, I think they're here. All right, I'm gonna get started because it doesn't seem like anyone else is gonna show up. So, hi everyone. So today we're gonna be doing the third ASHRAE workshop, which is 62.1, ventilation for acceptable indoor air quality. So to start off, basically I'm just going to go through what is ASHRAE to begin with, because we haven't really gone over this in a while, and I thought if we had anyone new, you might want to know what ASHRAE is. So first of all, ASHRAE stands for the American Society of Heating, Refrigerating, and Air Conditioning Engineers. And we mainly focus on building systems, energy efficiency, indoor air quality, and sustainability within the industry. ASHRAE has university chapters and city chapters all across North America and all around the world, which makes it really cool because it's able to share information through many different sources. It also helps students develop professionally and personally. So some of our values at ASHRAE UofT chapter specifically are to create a safe space, so an environment for members to learn off each other and support one another. We have a mandate to sustainability to serve the built environment and to shape a more sustainable future. And also we like to think that we have good networking here to build lasting connections with ASHRAE and the community and industry. So to start off, the purpose of ASHRAE Standards 62.1 is essentially to specify minimum ventilation rates and other measures intended to provide indoor air quality that is acceptable to human occupants and that minimizes adverse health effects. A large part of indoor air quality is making sure that people aren't breathing in air that is bad for them or contaminated by things that can be harmful. For use as a guide, to improve indoor air quality in existing buildings or to apply to new buildings. So this standard applies to all buildings, but there are exceptions. But first I'll go over the scope of ASHRAE 62.1. So essentially it is spaces in buildings except those that are residential and non-transient, which basically means just that they're contained to their household. So any home that has like just a family living in it, or is like, you know, out in the countryside all by itself. It also defines requirements for ventilation and air cleaning system design, installation, commissioning, operation and maintenance. And some of our other ASHRAE members will be going over those things tonight in more detail. And then it also contains requirements related to certain contaminants and contaminant sources, including outdoor air, construction process, moisture, and biological growth. The things it does not include are spaces that contain smoking, patient care areas not listed in the standard, and also laboratories, because they have hazardous materials that you can't really account for in a standard, and you need to kind of have a separate guideline for that. So just to start off with some basic definitions, acceptable indoor air quality, or IAQ, is air in which there are no contaminants at harmful concentrations, which is determined by authorities, and a substantial majority of people do not express dissatisfaction. Ambient air is the air surrounding a building, the source of air brought into a building. And then breathing zone is the region within an occupied space between planes of 1,800 meters above flow and more than 600 millimeters from the walls or fixed air conditioning equipment. That's pretty technical, but I just thought I would bring it up because it does come up a lot in the following slides.
Yeah, so I'm going to be talking about outdoor air quality now. And I'm going to be focusing on the importance of having outdoor air quality. How we actually measure this is by using regional outdoor air quality standards that are made for each country. And these measures are basically just guidelines that help us understand when a metropolitan area has unhealthy outdoor air quality because of high density populations and emissions. As you can see in the picture, there is a lot of unhealthy air quality in there. Okay, next slide. And yeah, so what we're actually measuring for are two different things. First one is PM 2.5, and they're these really small particles which are 2.5 micrometers in diameter. And you can see in the diagram that compared to a human hair, it's actually really, really small. And it can cause chronic health diseases and is one of the main contaminants that's present in outdoor air, coming from things such as smoking and smog. And on the right, you can see ozone, which is basically 3 molecules of oxygen. And it's very unhealthy for the area around it because it deteriorates vegetation and can also kill small animals. And this pollution can pollutant can also come from smog, and it comes from incomplete combustions inside of outdoor air. And Canada actually limits these Canada limits these concentrations to 30 micrograms per meters cubed per 24 hours for PM 2.5 and 65 parts per billion per 8 hours for ozone. Next slide. And why are we actually concerned about outdoor air quality instead of indoor air quality? Well, the obvious reason is that we want to keep our outdoor air fresh so that our indoor air stays fresh as well. And outdoor air quality actually contributes to a lot of sources when we determine indoor air quality. And the pollutants outdoors are very harmful to your health. And since it's outside, it can be minimized. But since the same air is traveling indoors, we have to make sure that the outdoor air is healthy as well. So for the indoor air, there has to be proper ventilation and air cleaning systems to make sure that there's acceptable indoor air quality to avoid these risks. And as you can see on the right, Toronto's current air pollution index is doing relatively well when compared to the rest of the world. And it can be seen that PM 2.5 is the most prevalent pollutant in our city, but we managed to keep it within a reasonable level. And that's it for air quality.
So we'll be going over some of the different kinds of systems and equipments described in Standard 62.1 in terms of the systems and equipment section. One very important part of systems and equipment is obviously particle matter removal. So the MERV rating ranges from 1 to 16. The higher the MERV rating on a filter, the fewer dust particles and other contaminants can pass through it. ASHRAE designed the MERV scale to represent a filter's worst possible performance at removing particles 0.3 to 10 microns in size. Some of the most common particles that filters are tested for include pollen, dust particles, carpet fibers, mold spores, pet dander, bacteria, and tobacco smoke. You might think that a higher MERV rating would automatically be better, but it's not. The higher the MERV rating, the smaller the pores are for air to flow through the HVAC filter. This can create more resistance in airflow than a system is designed to manage, thus making it inefficient. Therefore, these filters with higher MERV ratings need to be changed more frequently. Next slide, please. Next slide. Yeah. No. Building exfiltration. Yes. So building exfiltration is uncontrolled air leakage from the inside through unintentional openings in ceilings, floors, and walls to the outside, caused by pressure differences or temperature differences and imbalances between outdoor and exhaust airflow rates. From the picture, you can see the different types of airflow exchange, I guess, through different types of pressure. You have stack effect, wind, mechanical pressurization. So it's best to have a slightly more air intake than exhaust. This creates positive air pressure, which reduces dead spots inside the building. So it decreases air circulation and it prevents, it increases air circulation and it prevents dust from coming in through unfiltered openings. Next slide, please. Another important factor in systems and equipment is air classification and recirculation. ASHRAE divides indoor air into 4 classes that describe the level of contamination within the air in a given zone. Air classes are important because they govern the ability to recirculate air both within a given space as well as within a given system. Class 1 air is considered generally clean and without significant odor and is representative of the air in an office or classroom. Class 1 air can be recirculated to any space type, including 1, 2, 3, and 4. Class 2 air is considered moderately contaminated and odorous. This includes dining areas and fitness facilities. Class 2 air can be recirculated to similar Class 2, 3, and 4 areas. Class 3 and 4 are zones with significant contamination and odors. This includes janitor's closets, lab exhaust, and commercial kitchen exhaust. Class 4, therefore, cannot be recirculated even within its own self and must be immediately exhausted. Next slide.
Okay, so I'll talk about other systems and equipment that are important for ASHRAE 62.1, and this is the ventilation systems control. So mechanical ventilation systems need controls that are either automatic or manual, and this is to help the fan system operate to deliver specific loads. So the system needs to be designed to maintain the minimum outdoor airflow as required in Section 6, and that varies depending on the space. So whether that's an office space or an event space, ASHRAE has different standards specifying to each one, and a common one for fans is a variable frequency drive, which is a VFD, and these are motor controls that are good for saving energy because they adjust automatically depending on required air loading and control how much inflow and outflow you can get. Next slide. An additional system and equipment to consider is ozone generating devices or air cleaning devices that produce ozone. So any air cleaning device that uses electricity during the process to clean the air actually has the potential to generate ozone. And ozone generation is associated with certain things like high voltage coronas, pin ionizers, any type of UV light with a smaller wavelength can produce ozone. And as most of us know, ozone is harmful for health, like human health, and exposure to ozone creates a risk for a variety of different symptoms and diseases of the respiratory tract. So obviously it's not good to have ozone in your space to breathe. Obviously that causes issues, and there's little known about long-term effects. And although ASHRAE has a few safe ozone levels, there is a consensus that there's no necessarily safe level, and standards or like safe practice is just that ozone emission is like undesirable. So if possible, any alternative should be used instead, as this emission is negative and has a poor impact on the overall indoor air quality. So use caution with any type of ozone generating device. Next slide.
Okay, I'll be talking about the different procedures for determining minimum ventilation parameters. The ASHRAE standard includes 3 alternative procedures. The first one outlined here is the ventilation rate procedure, which prescribes minimum outdoor airflow intake rates for an occupiable space. These rates are determined based on physiological needs and subjective evaluation using guidelines and formulas from Section 6.2 of the standard. An example of this procedure being used is shown in the equation on the slide here, which shows how the minimum outdoor airflow required in the breathing zone of a space is calculated. So VBZ, which is the required airflow, is calculated based on the number of occupants in the space and the zone area, along with these R values, which come from the standard. Next slide. The second procedure is the indoor air quality procedure, where the required outdoor airflow intake rate for a space is determined based on performance criteria. So these criteria include contaminant sources, contaminant concentration limits, and the level of perceived indoor air quality. So some examples of contaminants are carbon monoxide, nitrogen oxides, and other volatile organic compounds. Each contaminant also needs to be minimized in its own way, so mechanical systems are then used to either clean or remove them from the space. This procedure is a really tedious process because it requires designers to first identify all the contaminants of concern, and then identify both indoor and outdoor sources of each contaminant and the emission rates from these sources. And then they have to specify a concentration limit for each of them, and then use mass balance calculations to determine the outdoor airflow rate necessary to fit these restrictions. So this procedure is not recommended for small scale projects because of how long and research intensive the whole process is. Next. The last procedure is the natural ventilation procedure, which is used in spaces where ventilation is provided from the outdoors through windows or doors. It prescribes the minimum outdoor air openings required for proper natural ventilation. It's not really recommended for this procedure to be used alone. Spaces rarely rely fully on natural ventilation because this way outdoor air temperature and weather can also come indoors, which may be detrimental to occupant comfort. So in most cases, outdoor ventilation is combined with other mechanical ventilation systems to maintain comfort, as shown in the picture here. So when this happens, when like natural and mechanical ventilation is combined, this procedure must be used in conjunction with one of the other two procedures. Next slide.
So I'm going to be talking a bit about the standard with respect to construction and then the starting up of either a brand new system or a revamped system. So during construction, the standard actually already covers this, and we need to use ventilation systems for new and existing buildings to remove dust, which is a major byproduct of construction. Systems also need to have filters where available to again remove, to catch these small particles. We also need to protect materials from additional moisture, especially insulation or wood, because this could cause rot and then rusting on steel as well. During system startup, we also have to be careful with respect to ventilation for newly installed air handling systems, as well as existing air handling systems undergoing supply air or outdoor airflow reduction. For system startup, ventilators need to be clean of all debris, which needs to be done prior to the startup of any system. And each ventilation system should be tested in order to demonstrate it works as designed. Can you go to the next slide, please? In terms of operations and maintenance, this is obviously for after the building has been constructed or renovated. And this maintenance may change if a major renovation takes place. The table here shows the minimum maintenance activity required for a building to meet the standard. So as we see here, the first thing is investigating the system for water intrusion or accumulation. And this doesn't have an actual value because it varies very much from system to system. But after a few years of having the system in place, you'll find out the frequency, and then it should be should be maintained at that frequency. After this, we need to verify the space provided for the routine maintenance and inspection is unobstructed, and this needs to take place every month, as well as the treatment to limit growth of microbiological contaminants every month. Finally, we need to verify the space provided for routine maintenance and inspection of equipment components is unobstructed, check for the pressure drop and schedule replacement dates of filters, clean or replace necessary filters, and then also check the ultraviolet lamp, and this needs to take place every 3 months. I'm not sure, did I cut out there? Okay, perfect. Finally, each of these systems will come with an operation and maintenance manual, and these manuals will override the standard with respect to maintenance, but also construction, because certain systems might have very specific needs. And I think with that, we have gone through the standard. So if anyone has any questions about any of this, please go ahead.
Yeah. Feel free to ask any questions you have. If anyone has any questions after this, you can always message us in our Instagram or our Facebook or anything like that if you want. I think I have the links here. It's just at ASHRAE UofT, or you can go find us on Facebook at UofT on Facebook, just ASHRAE UofT. And yeah, I think that's everything. If anyone has any questions right now, feel free to write in the comments or just turn on your mic and speak. I can turn off the share if people are uncomfortable with that. Who's still here? Okay, well, no one has any questions. I think that's everything, and I'll stop sharing. Oh, I think my... Oh, damn it.